features as they fill our solar system. And the solar system, as you know, is full of a fluid. We think of it as empty space, but it's actually a very tenuous fluid with turbulence, gusts, flows, and storms.
Well, it's interesting you speak of turbulence because you don't typically think of solar wind as having turbulence, but I guess now we'll find out. And as we send spacecraft into space, that becomes a real important thing to consider.
Absolutely. Astronauts, our technology, our spacecraft are all affected. I like to think of this as astrophysics at home because we're actually studying the astrophysics of the environment where we live.
Well, let's talk about space weather just a little bit more because we talk about the solar wind, but you said something to me earlier that it's less like wind, and you mentioned fluid. So how does that change the way we understand space weather, especially as it impacts things like spacecraft?
So space weather and the solar wind, which comes out of the sun all the time, is something we've often talked about as magnetic field mixed with particles. And that's sort of true, but it's really not the right way to think of it. There are so few particles in the solar wind. There's something like 10 atoms in the space of a sugar cube.
Wow.
Right? It's nothing. But those atoms interact with each other via the magnetic field. And so they act collectively, just like the air around us. We don't think of the molecules in the air. We think of the air itself.
Well, I tell you, I'm very excited, as you know, super excited about Punch. But what I'm also interested in, when we think of the space weather and how it interacts and protects our space weather, we're going to actually learn how it works, like what is happening on that long journey from the sun, which should help prediction. What are the things we're going to learn about how it functions?
Well, I like to talk about an analogy to human anatomy. Right? If we sample the solar wind, which is the main way we've studied it for 50 years, we learn everything there is to know about one point. That's like studying the human body using an electron microscope. Right?
Yeah, exactly.
So with Punch, we'll be looking at the larger scale and the cross-scale things. How is the solar wind connected? How do flows and turbulence evolve as they come out? What is this environment where we live? It's just very hard to view without a wide field view like Punch will provide.
You know, it's also interesting to me because SPHEREx also, but certainly Punch, it's not just narrow view. This actually informs scientists across disciplines. How will Punch help other scientists in other areas understand magnetosphere, solar wind, etc.?
So we will be tracking space weather, looking for effects like magnetosference, right? Interference with the magnetosphere.
Awesome. I did not pay him to say that. That's great. Yes, very important.
But the effects that we have to pull out of the data to get to what we want are useful in their own right. So we'll collect the world's best polarized starfield map ever made. We're probing high-altitude aurora in the outer atmosphere of the Earth. We'll track comets. All of these things are things we need to avoid for the science we want to do, but they're also very useful scientifically. So we hope to work with other missions.
I'm just overwhelmed, and I'm so thankful that Punch is flying and that we'll learn more about space weather. My good friends at Heliophysics branch at Goddard will be pleased. So thanks so much for being on the show, Craig. Really appreciate it.
Thanks for having me.
Absolutely. Now, we've learned about SPHEREx, and we've now learned about Punch. We need to go out to the pad and take a look at the rocket. Oh, wow, what a shot. Beautiful there on the central coast of California, the Falcon 9. Later in the show, very shortly, we're going to get an update on the launch vehicle from Franklin and Mick. But meanwhile, I'm going to go mix myself up a batch of Mission Punch. I'm very thirsty after Sue Chang's interview, so we should be good to go.
Thanks, Blair. I'm here with Mick Waltman from NASA's Launch Services Program. Mick, what is the status of the Falcon 9 as we prepare for this evening's launch?
Everything's been going great, Franklin. The team has done a great job to get us to tonight's launch attempt. We rolled the launch vehicle out to the pad here at Space Launch Complex 4 yesterday about 4 p.m. We put the Falcon 9 and the TE vertical about 7:30 p.m. last night. Got everything hooked up, ECS running into the payload fairing for SPHEREx and Punch, our primary missions today. And everything's looking good. Weather, everything great for tonight's launch attempt at 7:10.
What are the key milestones that the launch team looks at throughout the day that will lead them up to an on-time launch?
So first thing, team's going to come on about 3 hours before liftoff tonight. They will check all the batteries, make sure everything is going well on the vehicle electrically, and then they will start getting ready for propellant load. That is a key milestone that the team needs to do. At T-minus 43 minutes, the NASA launch manager, Dr. Denton Gibson, will poll the NASA and spacecraft teams to make sure they're ready to enter into propellant loading. SpaceX will then poll their team at T-minus 38 minutes, and we will start loading RP-1, rocket propellant number 1, and supercooled liquid oxygen into the Falcon 9. That is a key moment for the team because once we start loading propellant, we have committed to a launch time tonight. Again, with only a 30-second window for this mission, we need to be able to pick that time, and that 38-minute propellant loading mark is where we define our exact T0 tonight.
Mick, it was a crisp morning. When I sat up out here this morning, it was 40 degrees. Right now, the weather is really, really nice. You're in the short sleeves.
It's gorgeous.
Yes, it really is. No real chance for weather this evening, but if something popped up, what are the contingency plans for a launch beyond today?
Well, let me first address the weather. The Space Force launch weather officer yesterday briefed us, and she gave us an absolutely gorgeous weather forecast for launch tonight. 0% chance of violation, which means everything on the range is green and looking good from a weather standpoint. If there was some sort of weather that were to pop up, again, as I said, 30-second window that we have for this mission, so we don't have a lot of time to play with something. So if something were to pop up, the team would need to reassess that, decide what they wanted to do tonight, possibly even look at another launch attempt tomorrow.
Okay. Now, as we look at the Falcon 9, you can tell by the charring on it that this has been reflown. And exactly how many times has this first stage been reflown?
Yes, this Falcon 9 first stage is booster 1088. It will be its third flight here for the SPHEREx and Punch mission. It previously flew on NRO 126 mission and just as recently in January on the Transporter 12 mission, landing right back here at Launch Complex 4. Or at Landing Zone 4 and getting prepped and refurbished, ready to use for the SPHEREx and Punch mission. The team, again, has done a great job of that refurbishment campaign, getting the rocket ready. And as you can see behind us, we are vertical and ready for launch tonight.
You spoke about Landing Zone 4, which is just over my right shoulder over here. We are really close. I wish I could be here for the landing.
Yeah, Landing Zone 4 is only about 1,400 feet from the launch pad, or 426 meters. So that is incredibly close. The history of this pad, the launch pad is Space Launch Complex 4 East. The landing zone is Space Launch Complex 4 West, very close to each other. SpaceX reused both pads for launching and landing. It's exciting to see that right here on the West Coast.
What is it about the performance of the Falcon 9 that made this launch vehicle perfect for the SPHEREx and Punch missions?
So one of our jobs in Launch Services Program for NASA's agency is to be kind of like a broker, finding a rocket for a mission. So when SPHEREx and Punch was awarded by the agency to go do their science missions, NASA's Launch Services Program, we looked at all the requirements, the trajectory that was required for this mission, everything. We then looked into our catalog of rockets that we have that are commercial partners we work with. SpaceX was one of those, and NASA's Launch Services selected SpaceX to launch this mission as a great fit for what we need to get done tonight.
Mick, we have about a minute and a half left. What is the difference between a launch here at Vandenberg and one from the Cape or Kennedy, particularly in terms of trajectory and mission profile?
So one of the benefits of launching out here on the West Coast from Launch Complex 4 is being able to get into a polar orbit. For tonight's launch, we're going to head south over Antarctica to get into a polar or sun-synchronous orbit for these two missions. That is very easy to do from here on the West Coast. On the East Coast, we tend to lift off and go more into an equatorial type orbit. However, we can do polar orbits from the East Coast. It just takes a lot more energy from the rocket. So using the rocket to its most efficient benefit for the mission, we're launching SPHEREx and Punch from the West Coast today to get them into that polar orbit as quickly as possible.
One thing that we sometimes see during twilight launches is this kind of jellyfish effect in the sky. Can you tell us a little bit about that? Have a little bit of time left.
Yeah, so what happens is when you launch the vehicle and you get up into the lower atmosphere, stage 1 and stage 2 separate, and when that staging happens, you get to see this effect, the jellyfish, as you call it, effect that happens, especially at twilight, because you can see the light bouncing off of the plume that comes from the separation of those two stages. And then stage 1 heads its way back here to Earth for tonight at landing zone 4. Stage 2 then fires its Merlin vac engine and heads on into space to deploy our spacecraft. So it's an exciting thing to see, but it's just a normal effect that we see depending on what time of day the rocket launches.
Well, good stuff, Mick. You're going to be headed down to Hawthorne, where you'll be with NASA TV's Megan Cruz for the broadcast this evening?
Yep, Megan Cruz and SpaceX's Jesse Anderson and I will be commentating the launch from Hawthorne, California at Mission Control for SpaceX, and excited to do that.
Good stuff. Well, all eyes will be on Space Launch Complex 4 this evening at Vandenberg Space Force Base as the Falcon 9 prepares to launch the SPHEREx in-punch missions. Make sure you tune into the NASA broadcast, which will start at 6:15 Pacific Standard Time on NASA Plus and all of NASA's social media platforms. For Mick Waltman and the NASA television crew, we bid you farewell from Vandenberg, and we'll see you back here tonight.